Cuckoo search is an optimization algorithm, one of the swarm intelligence algorithms. It's inspired by broad parasitism of some cuckoo species. That birds laying their eggs in the nests of other birds species. Sometimes they threw away eggs or maybe even chicks. That was to make sure that a host will feed only cuckoo's offsprings. Some hosts can discover if eggs are not their own. It will either throw these alien eggs away or simply abandon its nest and build a new nest elsewhere. Some cuckoo species have evolved in such a way that female parasitic cuckoos are often very specialized in mimicry, in colors and patterns of the eggs of the few chosen species. Cuckoo search is based on three idealized rules. Each cuckoo lays one egg at a time and dumps its eggs in randomly chosen nest. The best nest with a high quality of eggs will carry over to the next generation. The number of available host nests is fixed, and the egg laid by a cuckoo is discovered by the host bird with some probability. In this case, the host bird can throw the egg away or abandon the nest and build a completely new nest. Here you can see an algorithm. Algorithm of cuckoo search can be divided into several steps. First step is initialization. There we initialize our objective function and first generation of host nest. Here in algorithm, axis play a role of coordinates of host nests, and function value of x playing a role of nest quality or fitness. And so then we sort nests by the function value. Other steps is in a loop that will stop in our chosen criteria. There is criteria. Levy flight. It is method some random older solution is worse than a new one. Then we replace host nest with it. Abandon and build there we abandon fraction of the worst nest and generate new ones. The last step is rank solution and pass the current solutions to the next generation. Levy flight is a function that imitates random walking of animals that seek food. It also helps imitate seeking of the nest by cuckoo. Cuckoo search can be improved. In standard cuckoo search, we use static value of probability of discover. It used while we abandon worst nest and build new ones, and step size alpha in Levy flight. To improve algorithm, we can use dynamic values of these parameters. On initial iteration, use large values to improve accuracy and smaller values on later ones. Here is a Rosenberg function. We use Cuckoo search to minimize this function. In mathematical optimization, the Rosenberg function is a non-convex function introduced by Howard Rosenberg in 1960, which is used to performance test problem for optimization algorithm. It is also known as Rosenberg Valley or Rosenberg's banana function. The global minimum is inside of a long, narrow, parabolic-shaped flat valley. To find the valley is trivial. To converge to the global minimum, however, is difficult. For this function, is global minimum is x is equal 1 and f of x axis equal 0. You can see there are three types of Rosenberg function. First one is pretty simple. It uses 2 dimensions. Next 2 is more complicated than it. In this slide, you can see results for different dimensions in Rosenberg function. Thank you. That's all.
Thank you. One last question. The extremum of Rosenberg function is not changing. The global minimum, what you're searching for, is changing with the dimension of the problem, or it stays the same?
It's the same. Axis is equal 0.
Okay.
Axis is equal 1, and f of x is equal 0.
Can you go back to the previous slide with the convergence figure? So in here, yes,
there,
yes. So in here, what I can see is that the minimum value for each line, the red one, orange, green, and blue, are different. Does it mean that the performance of the algorithm is getting worse as the dimension grows, or it means that only the value for the minimum value of the objective function is changing when we're changing the dimension?
No, it's not changing. Then the dimensions grows. Difficult of finding minimum growth.
Okay. So it's just the performance is decreasing, not the extremum is increasing, right?
Yes.
Okay. Thank you. Last question for you. What is the? I'm interested actually in the Levy function. Can you go back to that slide for the Levy function? Yeah, this one. Yes. So what is Levy lambda?
Levy lambda is is a function from random value lambda that that was in power -1 divided 3.
Levy is some kind of probability distribution function, or what? It's a random variable. Levy lambda is a random variable with parameter lambda.
It's a random value with parameter value. Yes.
Okay. Thank you very much. Very good. Thank you.